So we are going to continue our study of constant rate of change with something called slope. If you need to look it up, this is chapter 1, lesson 8 in your book. Slope. You mean like a ski slope? Well, actually, yes, kind of. They're related. So let's talk about what slope is. Slope is the rate of change between any 2 points on a line. It's the ratio of vertical change, up and down, to horizontal change, side to side. And if you think about what we just did with the constant rate of change and the graphs, this is the same stuff. They just didn't call it slope. Now, there are 4 different types of slope. We don't talk a whole lot about these in 7th grade, but I figure while we were talking about the ski slopes, we probably should. So if you read it from left to right, if you look at the graph as we would read a book, okay, this one looks like it's going up, that would be considered positive slope. If it looks like it's going down, that would be considered negative slope. If it's a perfectly straight horizontal line, that's what we call zero slope. That would be like cross-country skiing where you didn't have the benefits of downhill gravity. And then there's this one that's perfectly up and down, straight up and down or vertical. It's what we call undefined. Why? Because you can't ski up and down. That's called free fall. Now, you could have a really, really steep slope, either positive or negative, that looks like it's almost straight up and down, but you can actually ski on a really, really steep slope. They're like double black diamond, triple black diamond kind of slopes. So undefined. This is not something we will talk about in 7th grade, but I wanted you to know that they were out there. Some other words that you're going to hear a whole lot as we talk about slope are rise over run. Exactly what it sounds like. Rise is the change in vertical, and run is the change in horizontal. Now, fancy term for you, in science, when you take science in high school, you're going to learn that the triangle, sometimes called delta, actually means change. So if you didn't want to write all this out, you could actually say delta y over delta x. Or even one other, y2 minus y1 over x2 minus x1. Those are some really heavy-duty, mathy, fancy ways of saying all this. If you just remember rise over run, you'll be golden. Okay, let's look at a problem. It says graph the data about plant height for a science fair project. Then find the slope of the line. Explain what the slope represents in the work zone. All right, so let's graph this. They happen to have told us that the time will go on the x-axis and the height will go on the y-axis. So now I just got to make some dots. Week 1 is 1.5 centimeters. So week 1, and then I'll eyeball estimate where it goes, 1.5 centimeters. Week 2, we're up to 3. Week 3, we're up to 4.5. Week 4, we're up to 6. Now, in your head, if you're very good with your multiplication facts, you're like, oh, that just kept, adding 1.5 or doubling. Yeah, it kind of was. But look what happened. It formed a straight line for us. And even better, it goes through 0, 0. Now, what does that straight line tell me? It's a constant rate of change, which means I can find slope. The height grew by the same amount each week. Okay, so we kind of started talking about this already. You need to find 2 points. Let's go for those 2, okay? And we're going to subtract their vertical numbers. So here, this is at 6, and this is at 3. This look familiar? I feel like we did this yesterday. And then we're going to subtract their x's. This is at 4, and this is at 2. We found the rise, how much it went up, over the run, how much it went side to side. So we'll subtract, we get 3 over 2. It grew 1.5 centimeters per week. Okay? The slope is the number. The rate is the whole thing, or the rate of change. Okay? Now, there's another way you can do this. If these numbers are really, really big, you can actually count in between. So let's say, I'll even switch colors on you again. Let's say we do these same 2, right? We're going to say we're going to go up 1, 2, 3. That's a rise of 3. And then we're going to go over 1, 2. So there's my 3 over 2. Now, this should be the same throughout the whole entire graph. So let's start down here at 0, 0. I should be able to go up 1, 2, 3, and over 1, 2. Up 1, 2, 3, over 1, 2. Up 1, 2, 3. I kind of ran out of graph paper. Over 1, 2. And if I were to continue the graph paper or to continue that line, it would hit it. Now, we can do this 1.5 over 1 the same way. Let's go up 1.5 over 1. Up 1.5 over 1. Up 1.5 over 1. Tired of me saying it yet? It repeats. Up 1.5 over 1. Up 1.5 over 1. Okay? Every time I said that, it hit the line. All right, so the slope is 1.5 or 1.5. It means we grow 1.5 centimeters for every 1 week. All right, let's do another one. Ronaldo opened a savings account. Each week he deposits $300. Draw a graph of the account balance versus time. Find the numerical value of the slope and interpret it in words. Whew, there's a lot to that problem. I think, first of all, I need to get some data. So what are the 2 things that could change in this? What are the 2 variables? Time, the number of weeks, and money, the amount that he deposits. So let's make a chart. It can go side to side or up and down. I kind of think I'm going to do a side to side one. So this is going to be time in weeks, and this is going to be money. Right? And you only need a couple points. I would do more than 2. I would do, say, 3 or 4, just to make sure that you didn't make a calculation error. So let's say at week 1, he has put in $300. At week 2, he didn't take anything out, so that first 300 is still there, but he added some more. So now we're up to 600. Another week, another 300. Another week, another 300. And we can continue on and on and on. Now, we have to put this into a graph. Big hint, time will always be on the X. Always. Always. And then up the side will be his money. Now, super easy. Down here, I can count by ones. Up the side, you can pick whatever you want to count by. If you want to count by 300, do that. If you want to count by 500, do that. I think I'm going to count by 300. So the first line is going to be 0, the very bottom line. And then we'll go up 300, 600, 900, and we go on and on. 21, and then 24. Okay? I probably have more on here than I need, but that's okay. All right, let's make some dots. 1, 300. Over 1, up 300, make a dot. If you counted by something else, your graph might be slanted a little bit more. It might be a little steeper or a little shallower, but it should still make a straight line. This is a constant rate of change. All right, 2, 600, 3, 900, 4, 1200. And that's all the data I have. But if I line up with a ruler, I got to be precise about this. Here's what I love about graphs. And I missed a dot. Look at how much information I got like that. Because every time this crosses, I've got another point. It's a constant rate of change. I now have up to like 8 weeks worth of information. And I really only had to calculate like 3 or 4. Okay, so we need the slope. If I go up 300, I go over 1. Rise over run. Rise 300 over 1. Rise 300 over 1. Rise 300 over 1. Rise 300 over 1. Tired of me saying it yet? Because I can go on. Up 300 over 1. Up 300 over 1. So the slope is 300. I know, that would be like a crazy steep hill to ski. The slope is 300 to 1. What does it mean? Well, the rise was our money and the run was our time. So the rate is $300 per week. The slope is the rate. Let's say that again. The slope is the rate of change. You might want to chant that to yourself. The slope is the rate of change. Okay, if you're feeling pretty confident and you want to go get started on the practice exercises, go for it. I do have another example or two that I want to go through. You're welcome to stay and watch that. All right, here we go. Jessica has a balance of $35 on her cell phone account. She adds $10 each week for the next 4 weeks. Now, I need to explain this to you. Back in the day before Unlimited, you used to have to buy minutes. Okay, so she has $35 to spend. It's almost like a gift card or like a debit card. So you put the money on and then you use it, and then you have to put more money on if you want to make more phone calls. Okay, that's what they're talking about here. This is an old school problem. So she has $35 on her cell phone account that she's allowed to spend and make calls with. Then she adds $10 a week for the next 4 weeks. Down here, graph the account balance versus time. So here's your time, and here's your account balance, or how much you have to spend. Find the numerical value of the slope and interpret it in words. Okay, so let's make ourselves some numbers here to graph. So this is going to be time, and this is going to be money. Now, one thing that we didn't do on the last one, I didn't do a time of 0. What happens when she first starts? Well, on the other one, it was $0. He hadn't put anything into his account yet. But on this one, she's starting with a $35 balance. After 1 week, she puts $10 in. So now she has $45. I guess she didn't make any phone calls. This doesn't seem realistic. Most of us would have gone through that $35 in a week easily. But after 2 weeks, she still hasn't made any phone calls, but she added another $10. And then after 3 weeks, she adds another 10. After 4 weeks, she adds another 10. Maybe she was on punishment and she lost her phone, so she was just, racking up the balance for when she got it back. I don't know. All right, let's graph this. Now, this is going to look differently than our last graph did, because if I go over 0 and up 35, that's where my graph starts. It won't go through the origin. It won't go through 0, 0. All right, so we go over 1 up to 45. Oh, wait a minute. Not there. There. This gets even crazier. So halfway between would be 30, and then halfway between that and the next line would be 35. So it's really this one that I want. All right, 45. So there's 40. Halfway between would be 50. So let me drop it back down to 45. Go over to 2. Halfway would be 50. The next line would be 60. So we'll drop it back down to be 55 in the middle. Go over to 3. There's 60. Halfway would be 70, so we'll drop it back down to be 65. And then over to 4, halfway would be 70. The next line would be 80, so we'll go halfway in between for 75. Now, I can connect these. If I made some good estimations, it should make a pretty straight line. What do you notice? It doesn't go through the origin. That's okay. We can still find the slope. How much did I go up and how much did I go over? Each month I went up by 10 and I went over by 1. Sorry, each week. So up 10 over 1, up 10 over 1, up 10 over 1, up 10 over 1. It actually doesn't matter where we start for this case. We could do the same thing from the chart. We added 10, added 10, added 10, added 10, added 1, added 1, added 1, added 1. All right, so the slope is 10. What does that mean? That means she added, or the rate of change, by $10 each week. Okay?